In PSpice, setting component tolerance for its values and parameters enables you to perform simulation analysis like sensitivity and Monte Carlo analysis. To set tolerance, you can select and open the component's property editor and define the value of their parameter, tolerance. You can define a value with percentage or have different values for positive tolerance and negative tolerance separated by a slash. You can also define the distribution using dist property. By default, the distribution value assigned to each component is flat. PSpice provides different types of distribution, like Gauss, skew, bimodal, etc., which are present in the installation directory. To define tolerance for a component's model parameters should be edited to add tolerance and distribution, mentioned next to each model parameter. Dev specifies tolerance to individual components and will vary the parameter in the tolerance range for the selected component independently. Lot specifies the tolerance to all the components which refer to the same model, and the parameter value will be varied for all the components. You can also assign tolerance on a component SPICE parameter, which are based on a template. All the SPICE parameters get listed in the Simulation Parameters tab. For each parameter, the columns postol and negtol can be defined to set positive and negative tolerances respectively. The distribution column here provides a list of distributions present in the installation directory and can be set for each parameter. You can also define tolerance and distribution for all the components present in a circuit netlist using Assign Tolerance dialog. This lists all the components present in the circuit in two views, instance and model. In the global list, you can define the tolerance values in postol and negtol columns for all resistors and capacitors and defined a distribution too. The instance list is used to define tolerance and distribution to individual instances of a component. It also lists component SPICE parameters to set their tolerance and distribution individually in their respective columns and cells. This is how you can define the tolerances to components and simulate your circuit in PSpice.